I'm recording now. This is number 8. Okay. And what does it say?
A marble drops from a bridge, strikes the water at 6.0 seconds.
Okay, so this is an object dropped. So I'm just going to go straight into the motion map. When it says dropped, I think they mean dropped from rest. What do you think the initial velocity is?
0.
All right, so I'll make a dot up there to show that the velocity was 0 in the beginning. And these are my velocity vectors. This is actually very simple because it's just an object dropped and its beginning velocity is 0. And then, did the acceleration ever change?
Yeah.
Try again. So the acceleration is constant the whole time. And one way you can justify that is you can say, well, this is from the Earth's gravity that this thing falls, and the Earth's gravity surely didn't change. You get what I mean? So that's one way you can reason through it and say to yourself, well, this is constant acceleration. So that's a motion map for this situation. I do that so I can understand the story. And it looks like we have a time, so maybe I'll write down what I'm given. I'm given the time of how long? 6 seconds while it's in the air. And I know this is an object in free fall, right? So I know the acceleration. The acceleration is going to be 10 meters per second squared down. Now, which direction are you going to make positive? What do you want to do, up or down? Notice your velocities are down, your accelerations are down. You're allowed to make down positive, then your accelerations and velocities are positive, and that makes it easier. You good? All right. So to solve this problem, you can sketch the graphs. This is one way. All right. This is y versus t, and this is x versus t. Sorry, I messed up. That's velocity versus time, and this is acceleration versus time, right? And I'll just sketch them really quick. All right. Is the acceleration changing? So it's just 10 the whole time. And your velocity starts at 0 and changes by 10 meters per second every second. So it would be looking like that, right? And your accelerations are down, so their slope's positive on your velocity graph. I'm just adding units real quick. Then I can just think about the numbers. All right, so I know it takes 6 seconds, so maybe I'll label that on my graph, right? Oh, my position graph's just a curve that gets steeper, right? And then I'll have like this dotted line. So I'm going to solve the equation two ways. Solve this problem two ways. We want the speed at 6 seconds, or the velocity at 6 seconds. It says speed, I guess. And we want the height of the bridge, okay? So the equation of this line is the equation you asked about, right?
Yeah.
And that equation is V final equals AT plus V initial. We got that in the lab, so you can look back at the notes from the lab at how we got that. Now, do you notice that I also know my initial velocity. That's also given, so I'm going to write that down too, right? So V naught, initial velocity is 0. A is 10 meters per second squared down, which is positive. T is 6 seconds. Do you see how easy it will be to find my final velocity? I just multiply 10 meters per second times 6 seconds. Hey guys, have a good day. Good luck tomorrow. You notice the seconds cancels?
Yeah.
What is that?
Right? Seconds cancels. I'm trying to cancel that square. And then, so your final velocity at 6 seconds is just going to be what, 60?
No, 60 meters.
6 times 10?
Yeah.
60 meters. And that's positive, downward, right? Now, so that means that I can also find my displacement, how far this thing fell. And I would just find this area here. Now that I know my ending velocity at 6 seconds is 60, I can label it on my graph, right? And I can just find this area, which I already know is my change in position or displacement. So I got 60 meters per second times what? What's the time?
6.
6 seconds. And then I want to divide by 2 because that is a triangle. And that'll give me, I don't know, 30 times 6. I don't know what 30 times 6 is. 6 times 3, 18. So that's 180. And the units come out to be meters because my seconds cancel.
Mm-hmm.
And this is my change in position. So that's going to be the height of my bridge as well. So we found the height of the bridge, and we found our final velocity at 60 seconds. Now for fun, I could have used this area, which is just 10 meters per second squared times 6 seconds, and that would have given me a change in what?
Velocity.
Which is 60 meters per second, change in velocity. And you'll notice if we start from rest, my beginning velocity plus my change in velocity, which is just AT, will give me my final velocity, which is, again, that silly equation we just used. So the graphs and the equations are the same thing. They're just two ways to express it. You guys good?
Yeah, I'm good.
Hee hee.